Here's our opener. I would like you to pause the video and go ahead and solve that quadratic equation any way you know how. My guess is you chose one of these three ways, either guess and check. You should have done something like this, just pick a number. Well, I know 7 squared is 49, so this must work. 2 plus 5. You could have factored. Remember when you solve it by factoring, it's not x equals -5 and x equals -5 because this doesn't equal 0. You have to get it equal to 0 first, then you can factor and go from there. And then graphing, you also have to get your equation equal to 0 and then find where x intercepts. So my guess is you chose one of those three ways. If you need to look at them further, go ahead, pause the video and look at them. But I'm going to put one more way up here that actually I probably would have used. Okay, this, sorry I didn't write it, is solving by square rooting. You might say, well, hold on, how in the heck are you square rooting? Because by my calculation, you have 1, 2, 3 terms. And you told me last lesson or whatever lesson ago that you can only solve quadratics by square rooting if you have 2 terms. We got to look at the grouping symbols. This parenthesis is grouping this together, creating one binomial, which is one big term, one big group. So because that group is being squared, we then can square root it because it's like one term is being squared. So we can undo that square by square rooting. So here I square rooted both sides. X plus 5 squared equals the square root of that equals the square root of 49. We all know the square root of 49 is 7. Notice I circled the plus and minus 7 because positive 7 squared equals 49 and negative 7 squared equals 49. So what you do with that plus or minus 7 at this point, we have x plus 5 equals positive 7 or x plus 5 equals negative 7. So what I did is I solved for x. I subtracted the 5. And I said, okay, negative 5 plus 7 is 2 and negative 5 minus 7 is negative 12, leaving us with 2 and negative 12. We're going to use this step in solving quadratic equations in this new method, which is solving by completing the square. So let's take a look at it. So this problem I have here in the middle is a different problem than was at the beginning. This is 5.7, completing the square like you saw. The purpose of completing the square is to transform the trinomial side of the equation into a perfect square like we have right here. X plus 5 squared is considered a perfect square because it's a binomial times itself, hence x plus 5 squared. Notice the right side is not a perfect square, it's 49. Or sorry, it's 14. 49 is a perfect square. That's not a perfect square, and that's okay. It doesn't need to be. So therefore, the right side, when we solve this, the right side of the equation may still have a radical, or it may even be a complex number when we simplify it. First, this is just telling you examples of perfect square trinomials. You can see them here. Go ahead, pause the video. If you have questions, you can ask if you can see the pattern. Notice the last one, I don't have anything because they're not the same binomial. Let's solve the quadratics by completing the square. Now, first thing you need to ask yourself is you need to look at your trinomial side, so this x squared minus 12x plus 5, and say, all right, are you a perfect square trinomial? Can I factor you into the exact same binomials? And there's no way we can. So what we need to do is find the c term that we can use to factor it. So let's get rid of that 5 right now. So let's go. Okay, great. Now, how do we identify this value? It's actually very quick and very easy. And kind of like you can see back here, if you notice this 10 and 25, 10 and 25, 8 and 16, 24. This was a different example. So look at these first 3. So the biggest thing we can do here, think, what can you do to 10 to get to 25? What can you do to 8 to get to 16? It's not necessarily what you can do to these numbers. It's if we take half of 10, that's 5 here. And what happens when we square 5? We get 25. So the quick way to identify that c term, it's written right there for you. You take half of your b term and square it. Our b term is negative 12. Half of negative 12 is negative 6. What happens when we square anything, whether it be positive or negative? turns to a positive number. So negative 6 squared is positive 36. All right, you might say, hold on, you added 36 to the left-hand side. Why is there also plus 36 on the right? It's an equation. If you do something to one side, what do you have to do to the other? Like in the first step, we subtracted the 5 from the left side and from the right side. That's why there's negative 5 over here. Here, we're adding 36 to the left side, so we also have to add it to the right side. So let's go ahead and simplify from here. We will factor the left side. At this point, we're pretty good in factoring, so we should know that it goes to x minus 6 times x minus 6. Now, honestly, when I solve problems by completing the square, this step I skip. I'm just writing it out for you guys to see it, so you know how I'm getting down to this next step. So when we factor this trinomial, it factors to x minus 6 times x minus 6. Check your OI, it all works out. But because this is written, or because it's the same binomial, we can rewrite it as x minus 6 squared. And then here I just simplified the right-hand side. Negative 5 plus 36 is 31. Now we have exactly what we had on the opening screen, so now we can solve it. Technically, you could do it by graphing, but I want us to get used to completing the square. So we're going to solve it by square rooting, just like we did. So let's walk through that. And there you have it. You square root both sides. Square root of 31, or 31 can't be broken down, can't be simplified. It's prime. So our final answer is 6 plus the square root of 31 and 6 minus the square root of 31. So it's written just like that. So it's an irrational number. You could approximate it and find the decimal. However, I'm going to be pretty strict and I want your answers written in this form. Let's go ahead and try one more example here. You might say, hey, this one's easy. We got that minus 4 there. This is already a perfect square trinomial. And I'm going to tell you close, but not exactly. Because look at your C term. What is it? It's negative. It's impossible for your C term to be negative in order for it to be a perfect square trinomial. So once again, we have to get rid of that C term and do half of our B term and square it to get the appropriate C term. Okay, here, no different than the first one. We add the current C term over, add the 4 over. We need to find the C value that needs to go there. So we half our B term, which is 2, and 2 squared is 4. So we add 4 to both sides, which gives us then, once factored, x plus 2 squared equals 8. Then we solve it by square rooting. So I square root both sides, and we get x plus 2 equals plus or minus the square root of 8. Square root of 8 simplifies to 2 square root of 2. Therefore, we have x equals negative 2 plus or minus 2 square root of 2. I want you to go ahead and try this problem, x squared minus 8x plus 36, on your own. So pause that video and do that. There's my steps. I did skip writing a few of them like I said that I would, but your final answer should be 4 plus or minus 2i square root of 5. If you did not get that, go back and look at the steps, or make sure you write your questions down right now so you can ask me in class tomorrow. Go ahead, ask yourself that question. What ways can we solve quadratic equations? In what ways? So go ahead, answer that question yourself. You should be able to have 4 responses there. 5x squared equals 6x plus 8. You might say, okay, now why'd you move everything over? You're going to have to move that 8 back over, so why'd you move it over in the first place? And the answer to that, what makes this more difficult, is our first term. Notice in all the other examples we did, it was always x squared. We had a 1x squared. Our quadratic term had a coefficient of 1. Notice in all of these, that's not the case. So what we have to do is we have to make, in order to solve by completing the square, so this is what makes solving by completing the square difficult. In order to solve by completing the square, your a value has to be 1. So what we need to do here to make it 1 is divide everything by 5. So let's do that. Notice I left everything as fractions. I would prefer you do the same because it's going to make simplifying it when we take the square root a lot easier. So let's go ahead and now, just with this, go through the same process we did in solving by completing the square. All right, let's walk through this. So we divided everything by 5 and got that, moved the 8/5 over. right? So we did that. We had x squared minus 6/5 x equals 8/5. Well, then we have to find that c term. This is where the trick of knowing that this is just going to be half the b term, it makes things a lot easier, because you might look at that and say, well, how in the heck do I factor x squared minus 6/5 x plus 9/25? You're right, it does make things a little bit more difficult. So that's where knowing that trick, that it's just going to be half of your b term right in here, helps out. So we have x minus 3/5 squared equals 8/5 plus 9/25. How I did that, remember, to add fractions, you need a common denominator, which in this case would be 25. So I multiplied both the numerator and the denominator by 5 here, which gave me 40/25. So then once I had that common denominator, you add the numerators. So I got 49/25, and then simplified just like we did, square rooted. When you square root a fraction, you square root both the numerator and denominator. So we got x minus 3/5 equals plus or minus 7/5. Then we add 3/5 over 3/5 plus 7/5 is 10/5, which is 2. 3/5 minus 7/5 is negative 4/5, which we have there. If you're curious how I got the 3/5, 6/5 divided by 2 is 3/5. And then remember, we have to take half our b term and square it, and that's where the 9/25 came from. So there's all that work. Why don't you guys go ahead and try this second example here? There you have it. You should, after you work through all your steps, get -3/2 and -2 as your answers. Make sure any questions you have, you write down and you bring it in tomorrow. We can discuss it. Thank you. Have a nice day.